Hi there. Now, for part B of this question, we're told that given that P is a point on the curve C with this equation here, such that f prime x or f dash x equals -1, we've got to now find the coordinates of the point P. So in order to do this, first of all, what I need to do is just figure out what x would be when f dash x equals -1 here. So we just equate this to -1. Once we found out what x is, then we can substitute it back into this equation here and hopefully get what y is. And then that will give us the x and y coordinates of the point P. So that's the method. Let's just go for it now. So we've just got here when f dash x equals -1, then therefore we've got f dash x is this, so that's -9 all divided by x minus 2 all squared. That's going to be equal to -1. Rearranging this, multiply both sides by -1 and times by x minus 2 all squared. That gives x minus 2 all squared equals 9. And if I square root both sides, much quicker than having to expand this and then subtracting 9 from both sides and refactorizing it. So if we just square root both sides, we get x minus 2 equals plus or minus the square root of 9. In other words, plus or minus 3. And so all I need to do next is just add 2 to both sides. So therefore we end up with x equals 2 plus or minus 3. And that leads on to x equaling 2 add 3, which is 5, or x equals 2 minus 3, which is -1. But it says that x is greater than 2 here, so it can't be -1. So since x is greater than 2, we know that therefore x must be equal to the 5. So now that we've got x equals 5, we can just say that when x equals 5, work out now what the corresponding y value would be just by doing f of 5. So f of 5, let's put a therefore in there. Therefore f of 5 would equal 4 times 5 plus 1. And that's all divided by 5 minus 2. So in other words, we've got 21 divided by 3, and that's going to be 7. So that means that therefore the point P has coordinates 5, 7. Okay?